It's dark here, and I can't see you. But wait! We see things every day, from the moment we get up in the morning until we go to sleep at night. We look at everything around us using light. Without light, you wouldn't see anything at all. Light is a strange thing. It isn't just what we can see. Light can be broken up into different types, and we call the whole family the electromagnetic spectrum, which was discussed previously. And now we will be focusing on visible light. We often represent light as a wave. Just like a water wave, light has a wavelength, a frequency, and a speed. The different colors of the optical light have different wavelength, and so does the rest of the electromagnetic spectrum. In our previous lesson, we learned that electromagnetic waves are arranged with decreasing wavelength, and that means electromagnetic waves are arranged with increasing frequency and energy. Visible light is made up of many colors. There are 7 colors of light in a spectrum: the red, orange, yellow, green, blue, indigo, and violet, or the Roy G. Biv. And these colors are also arranged with decreasing wavelength, increasing frequency, and energy. Light is the fastest thing in the universe. In a vacuum, all light waves travel at an incredible speed of 300 million meters per second. Did you know that thunder and lightning start at the same time? But we saw the lightning first because light travels faster than sound. Did you know that it takes around 8 minutes for a light wave to travel from the sun to the earth? And did you know that we see the moon because it reflects the sun's light? It takes 1 second for light reflected off the moon to reach the earth. There are 2 types of light: the sun, lightning, certain type of glowing insects, worms, and fishes are all examples of natural sources of light, while the candle flame, torches, lamps, and light fixture are among the artificial light sources. Some objects can generate their own light. For instance, the sun, fluorescent bulb, burning candles. The objects which generate their own light are called luminous objects. Almost all of the objects that we come across cannot generate their own lights. Table chair, wallpaper, and few of the examples are non-luminous objects. Can we see the objects outside the window? Nope, we can't. But the question is, why? It's easy, because the light from the outside of the window does not reach us. The wooden window blocks this incoming light. Such objects are called opaque objects, and they are very large in numbers. Almost everything around us is an opaque if you think about it. Wood, metal sheets, colored plastics, and so on. Let's open the window. Can you see something new? We see the surroundings through the glass. We have a clear glass which allows light to pass through it, allowing us to see through it clearly. Such objects are called transparent objects. Now look at the shelf which has a milky glass. Are we able to see what's inside? Well, we can't see the things clearly, but do you see something, right? Yes, milky glass allows light to pass through it but only partially. Those objects that let some light pass through are called translucent. Now let me ask you this question. What kind of an object is a human body? Are we able to see through it? Not really. Hence, it is an opaque object. There are things that are required for a shadow to be formed. First is the source of light, opaque object, and the surface on which the shadow can be formed. Transmission, reflection, refraction, diffraction, absorption, and scattering are all typical wave behaviors. When light waves pass across the boundary between two substances, like air and glass, they change speed. This is because the substances have different densities. The change in speed causes the waves to change in direction, which is known as refraction. Did you know that because of refraction, things in water look closer than they really are? Water appears shallower than it really is. And the straw of glass in water looks like it bends on the surface because the refracted light wavelengths makes you think the straw is in a different place to where it actually is. Transmission is when waves keep traveling in the same direction through an object, like light through a window. Absorption or reflection often go hand in hand for light waves. White light contains each wavelength, so all the colors of the visible light. The color of an object depends on which wavelength of light they absorbs and which they reflects. White objects reflect all the light that hits them and absorbs none. Black objects reflect none, instead absorb all the light that hits them. A red object absorbs all the wavelength except red, which is reflected. And a green object absorbs all the wavelength except the green, which is reflected. Did you know darker car is hotter than a white car in the summer? This is because light is energy and so is heat. A black car absorbs all wavelengths of light, absorbing the energy and turning it to heat. Observe the video. When a group of parallel rays strikes a smooth, flat surface, the reflected rays are parallel to one another. Then the reflection is regular. But if it strikes a rough surface, the normal line is different for different rays. As you can observe, thus, the reflected rays are scattered in all directions. This is called a diffuse reflection. When we stand in front of a plain mirror, we can see ourselves inside the mirror. When we wave at the mirror, our image inside also waves back at us. What are the characteristics of an image formed in a plain mirror? The image formed in a plain mirror is upright. This means that the top and bottom of the object are the same as the top and bottom of the image. The image formed in a plane mirror is laterally inverted. This means that the left and right sides of the objects become the right and left sides of the image respectively. The image formed in a plane mirror is of the same size as the object. This means that the image has the same height and the same width as the object. The image formed in a plane mirror is the same distance away from the mirror as the object. In other words, the image distance, which is the distance between the image and the mirror, is equal to the object distance, which is the distance between the object and the mirror. Finally, the image formed in a plane mirror is a virtual image, which means that the image cannot be formed on the screen and that the image is not really behind the mirror. The image of an object is formed in a plane mirror because the light from the object is reflected by the plane mirror, making it seem like the light comes from behind the mirror. At the surface of the mirror, the normal line is an imaginary line perpendicular to the surface. Incoming light ray directed at the surface is called the incident ray. The light ray that bounces off the surface is called the reflected ray. The angle of incidence is the angle between the incident ray and the normal line. The angle of reflection is the angle between the reflected ray and the normal line. When a light ray is reflected, the angle of incidence is equal to the angle of reflection. This relationship is called the law of reflection. Did you know that if you want to see your full image in the plane mirror, regardless of how far you are from it, the minimum size of the mirror you need is half of your height. However, the base should be positioned at half the distance between your feet and your eyes.